Section 2.2 Applications of Linear Equation. So in the last section we learned how to solve linear equations. In this section we're going to take that idea of solving linear equations and apply it to real life problems. So what we want to do here is they'll give us a word problem. We want to read it. We want to write down things that they've told us in the word problem, things that we're trying to find. We want to create an equation out of that word problem that we can solve. Okay? And it's really something hard to teach to students because every word problem that you come across is going to be different. So what we want to do here is have some basic guidelines for solving word problems, and then that's the first thing we want to do. The second thing we want to do is just expose ourselves to as many different word problems as we can so that we can get confidence solving word problems and hopefully apply the techniques and things that we've learned with some specific word problems to other word problems that we haven't seen yet. Okay, so that's the main thing. It's a huge challenge with word problems, but it is something that you can do. It's something that we need to do because it's you're going to see these types of problems on the test and so on. So we just need to, make sure that we understand the guidelines and make sure we do as many different problems as we can so that way we can get some confidence solving word problems. So to that end, let's get started with some basic guidelines for solving word problems. And again, I do want to specify, I'll just capitalize the word basic. And these are basic because they might not apply to every single word problem, okay? And these guidelines can be used not just for this section, but pretty much any section that involves word problems, okay? Again, I do want to stress very much that you might not be able to use these guidelines for every word problem, but it's a place to start. The first thing we want to do is we want to draw a picture if we can, if it's a geometric problem. So if you're dealing with the area of a rectangle or something like that, we might want to draw a picture to help us out, or a triangle or something. The second thing is we want to write down, create variables for the knowns and the unknowns. So we want to basically write down the knowns and the unknowns by creating some variables. They'll tell us something. They might tell us in the problem the length of the rectangle is 12 feet, so we might want to create a variable L is equal to 12 feet and so on. Okay, so we just want to do that. Okay, the next step is we want to find a formula, okay, that relates the knowns and unknowns. So this is the hardest step. We want to find a formula that relates the known and the unknowns, and this is the step that creates an equation. Because if you recall, an equation has an equality in it. What do all formulas have? They have an equality in it. For example, the formula for perimeter is what? Perimeter for rectangle is P is equal to the twice the length plus twice the width. In essence, this is an equation because it has an equality in it. Okay, if I know some of these quantities, I can find the missing quantity then. Okay, so basically when we find a formula that relates the unknowns and the unknowns, we're really creating a equation out of it. The next thing we want to do is we want to make sure the formula in step 3 has only one unknown. So like for example, this formula right here, this formula has 3 unknowns: perimeter, length, and width. So somehow we want to use some of the information that they've provided us in the problem to get rid of at least 2 of these unknowns. So let's say that I replace this with 60. They tell me that the perimeter is 60, and they tell me that the length is the width minus 2. So if I do that, now I have an equation that only has one unknown, the width. Okay, so that's what we want to do in this step, another very important step. And then the next thing we want to do is, the last thing we want to do is we want to solve. Because once we are down to one unknown, we can solve that. We know how to solve a linear equation. And then the last thing is write the answer in a sentence. And that's something students always forget. They're so used to solving equations up to this point that once they get an answer, they'll get x is equal to 3, or they'll get the length is equal to 3, and they'll box it and they'll say, okay, that's my answer. No, they asked you the question was in form of a sentence. You need to answer in form of a sentence. So you can't just say L is equal to 3. You need to say that the length of the rectangle is 3 feet. That's what you need to do. Okay, and you should always, when you solve, you should always check your solution. We've always talked about that in the previous sections, so make sure you guys check your solutions. So these are some basic guidelines to solving word problems. And again, I really do want to stress this, that these might not work for every single word problem, but it's a great place to start. Okay, so let's take a look at some word problems that I've already typed up. Okay, and these are the same word problems from your notes, so hopefully if you struggle with this here in this video, you can go back and refer to your notes. The word problems in the notes are done a little bit differently than the way I'm going to do, which is good because you can look at two different methods here and try to pick the method that works for you. So if you don't understand the method that I'm teaching you in this video, maybe go back and look through your notes and see if that's something you can work with. Okay, so let's get started. In the first word problem, they say in a certain algebra class, there's a total of 350 possible points. These points come from 5 homework sets that are worth 10 points each and 3 final exams that are worth 100 points each. A student has received, so let's just write down what they've told us so far. So basically there's 350 total points in the class, and they come from homeworks and tests. And there are 5 homeworks, each is worth 10 points. Okay, and there are 3 tests, each is worth 100 points. I'm just writing down roughly what they've given us. Okay, alright. A student has received a homework scores of 6, so they've scored 4, 8, 7, 7, and 9 on the homework. Okay, and they have, assuming that the grade, and on the 2 tests they've scored 78 and 83. Assuming that the grades are assigned according to the standard scale, which is basically 60, 70, 80, 90 scale. That means this is at A, B, C, and D, sort of. Okay. Assuming that they're assigned a scale and there's no weights assigned to any of these grades, is it possible for the student to receive an A in this class? And if so, what is the minimum score on the 3rd exam that will give an A? And this is a nice problem because you might be interested in just find out what you should score on the final exam here. Okay, because you should have 3 exams here, so that you can get an A in the class. So we don't know what he or she is going to score on the final exam. So let's create a variable for that. So we can go let x equal to score, not on the final exam, but the 3rd test, score on the 3rd test. Okay, so we have a variable, and that's the only unknown we have in this problem, and the knowns are all given to us right there. So I've written all of those down. We don't need to create variables for that this time. Okay, now we need to come up with a formula that relates everything that's given to us, that relates all of this and this. Okay, so let's do that. They're basically talking about finding the average in the class, your class average. Once you know your class average, you can do that. I'm sorry, there's one other thing they've told us I should mention. That's the first part of the problem. They've asked us what should you score on the 3rd test so that you can get an A in the class. To get the A in the class average should be what? Your class average should be at least 90% or higher. Okay, so in this case it should be 90%. Alright, so let's see how we can relate all of this. Just from basic averages, we know that the average in a class is equal to the points scored, and this is just a formula that we should know from basic math. Points scored divided by total number of points, total points. That's how we calculate average in a class. We take all the points that we've scored divided by all the points that were available. So in our case, let's start using this formula. So we came up with this formula. So now we know the average is 90%, so we can write it as a decimal 0.9. And the point scored is all the points that we've scored in this class so far, which would be 4, 8, 7, 7, 9. So we get 4 plus 8 plus 7 plus 7 plus 9, plus the points on the test, which is 78 plus 83 plus x. Remember, the x is the points on the third test. That's the total points in the class divided, that's the total points scored in the class divided by the total points in the class, which we already know is 350. So there's your equation. We have an equation which only has one unknown, so that's good. It's a linear equation. It's an equation, you can see. I have this over 1, so you technically have two fractions equal, so you know from earlier we can cross multiply and do them much faster. If you don't want to cross multiply, then you can find the common denominator, which is 350, and multiply both sides by it. But before I do all of that, let me go ahead and add up some of these numbers. We have all of these numbers, and you can quickly add them up. It's not that difficult to add that up. So if you add them up, we end up with 196 plus x divided by 350. So there's an equation. This is the kind of problems we dealt with in the last section, solving linear equations. This is over 1, so we can cross multiply. We can send this over there, this over here. So we get 0.9 times 350 is equal to 196 plus x. Okay. And then you can multiply this on your calculators. It's not that difficult to do. It's 315. So we get 315 is equal to 196 plus x. So to solve for x, you move the 196 to the opposite side. So we get x is equal to 315 minus 196. So we get x is equal to 119. So let's answer the question that they had asked us. They asked us that, is it possible for the student to get an A in the class? And if it is, what should he score on the third test? Well, each test is out of 100 points. So on the third test, he needs to score 119 to get an A in the class. And that's not possible because the test is only out of 100 points. So the answer to this question is not possible to score an A in the class. And again, you notice I'm writing my answer in terms of a sentence because they asked us a question in terms of a sentence. Okay. The second part of this problem, if you go back and look at it, is it possible to get a B in the class? Okay. So let's take a look at that. So the problem is going to be the same. So I'm not going to reinvent the wheel here. I'm just going to take this and call it 2. Except now to get a B in the class, the student needs to score 80%, because 80 or higher is a B, between 80 and 90 that is. So now the only thing that changes is this becomes 80, so I'll change that to 80. And then this also becomes 80. I can still cross multiply and do this. This becomes 80. Everything else over here changes now. So let's do the rest. So 80 times 350 is going to be 280. Is equal to 196 plus x. So you move the 196 to the opposite side, so we get x is equal to 280 minus 196. So we get x is equal to 84. Okay, so the student needs to score an 84 on the third test to get a B in the class, and that's possible because the test is out of 100 points. So the student needs an 84 on the third test to get a B in the class. Okay, so that's what the student needs. Okay, so you can see these problem, we set it up exactly using a guidelines we defined earlier. We said that we wrote down everything that was given to us. We created a variable for the unknown. We also wrote down what we needed to get an A in the class, 80%. We had to come up with a formula that relates everything. So we created our own formula, which is average is equal to the points scored divided by total points for a class. And then we plugged in everything and created our equation that we solved by cross multiplying. Okay? Alright, let's take a look at the next question. In this next question, it's a geometric question because we're building shelves. So we want to build a set of shelves. Okay? The width of the set of shelves needs to be 4 times the height of the set of shelves, and the set of shelves must have 3 shelves in it. If there is 72 feet of wood to be used to build the set of shelves, what should be the dimensions of the set of shelves? Alright, so let's take a look at it. Okay. Alright, so let's draw a picture in this case. That might be helpful. Okay, so they've told us that we want to create shelves. Okay, so there's going to be 3 shelves. So this is shelf 1 up here. Okay, this is shelf 2, and this is shelf 3. So we have 3 shelves. This is the width of my shelf. I'll call that W. And this is the height of my shelf. I'll call that H. Okay. Now, so I created my unknowns already in this picture, so I don't need to define them. If you have a geometric picture that is used to define your unknowns, the width and the height, then you don't need to say H is equal to height, W is equal to width. You can see that from the picture that that's what it is. So we don't need to define them again explicitly. They've told us that we have 72 feet of wood to use to make these shelves, and they've also told us that the width of the shelf needs to be 4 times the height. So they've told us 2 things. So let's put those down. So let's start with the first one. They've told us that the width, anytime width of the set of shelves needs to be 4 times, so it should equal to 4 times the height. Height is H. Remember, the height is H, width is W. So we got that done. The next thing is they've told us 72 feet of wood. So think about it. If I have 72 feet of wood, I'm going to use that to make this side, this side. I'm also going to use that to make all these sides also. So whenever you talk about the outside of a geometric shape, a good way to represent that is by calling it the perimeter. So in this case, they've told us that the perimeter of this is going to be 72 feet. So this is what's given to us. Okay, they gave us this, we were able to draw this nice picture to help us out, and they told us a few things about the relationship between the width and the height, and they've told us something about the perimeter. Okay, so now we need to come up with a formula that relates the knowns and the unknowns. This is known, and these are my unknowns. So I want to come up with a formula that relates that. Well, my P, if you think of that as your perimeter, is going to be used, or the amount of wood, you're going to use it to make this side and this side. So it'll be 2H, because I'm going to need, each side is H, plus I'm going to use that wood to make this top, middle, these middle 2 sides and the bottom. So it's going to be 4W. So there's your formula that you're going to use in this section for this problem. So this is an equation. Again, you can see the equality. Now let me go back to the original start. We drew a picture of this case. We created the variables for the knowns and the unknowns, and then we came up with the formula to relate it. Now comes the important step. We want to make sure that the formula has only one unknown. So let's go back to our formula and see how many unknowns we have here. Well, we have 1, 2, and 3. So let's put in as much information that's given to us and see if we can get it down to one unknown. Do we know the perimeter? Sure, it's 72. So let's plug it in. I have 72. I have 2H. I don't know the H, but I do know the width. The width is what? According to this, is 4 times the height. So it's 4H. That's good, because now this equation, this one had 3 unknowns, this one only has 1. We know how to solve that. We want all the variables on one side, but before we do that, we want to get rid of the parentheses. So let's just multiply here and get rid of those parentheses, and then make sure all the variables are on one side. So we get plus 16H. They're already on one side, so let's collect those variables. So we get 18H. Okay. And then we want to solve for just H, which is attached by multiplication to the 18, so divide by 18. So you get H is equal to 72 over 18. Okay, so what do we get for H then? H is equal to 4. So you don't want to box this and say that's my answer. No, that's not the answer. That is just the height. And the answer should always be in terms of a sentence. They want the dimensions of the shelf. So the height is 4. And what is the width? Because the dimensions are width and the height. What is the width? The width is going to be 4 times the height. So the width will be 4 times 4, which will be 16. So my width would be 16. So this would imply my width, which was given to be 4 times h, so it'll be 4 times 4, which would be 16. So now let's write an answer in a sentence. So then we can say the height of the shelves, and that's what they remember. They've asked us for dimensions. Whenever they ask you for dimensions, they're asking for both length and the width and the height. The height of the shelves is 4 feet. Remember to put the units in. And the width is 16 feet. And that's your answer. I always like my answers boxed, so it's always a good idea to box them. So this was a nice problem where we could draw a picture, write down the knowns and unknowns, come up with a formula, and we just use a little bit of common sense. Say, okay, this is how much wood I have. I'm going to use the wood to make this side, so that's 2h. And I'm going to use the wood to make all the shelves, so that's 4w. And we set up our problem that way. Made sure it had one unknown, and we went from there. Alright, the next problem has nothing to do with geometry, but has to do with money. So let's take a look at that. They've told us a calculator has a markup of 15% and is being sold for $78.50. How much did the store pay the manufacturer of the calculator? Before I do that, let me just tell you what happens. Let's think of the store as the bookstore. You're buying a calculator at the bookstore. Okay, so what would that mean? The bookstore is going to buy the calculator from, let's say, from Texas Instrument. Okay, just to give you an example, they buy the calculator from Texas Instrument for $100. Now they're not going to turn around and sell it to you for $100. They're going to mark it up. So they're going to mark it up by, some percentage. So let's say they mark it up by 20%. So 20% of $100 is what? You take 20%. Oops, not a decimal. 20% of 100, which is the same thing as 0.2 times 100, which would be $20. So they're going to mark it up by $20 and they're going to sell it to you for $120. This is just something all businesses do. They buy it from a manufacturer, from someone who makes a calculator for a fixed amount. Then they mark up the price and they sell it to you for a certain amount. And the markup is usually some fixed percentage of what they paid for the calculator originally. So let's use this idea to do this problem. Okay. So first of all, they've told us that the selling price of the calculator, what they sold, I'll call it SP. The selling price of the calculator is $78.50. That's given to us. The markup rate, I'll call that R. My markup rate is 15%. So this is the markup rate. So the question is, how much did the store pay for the calculator? What was the original price of the calculator before the markup? So let's call that OP. So we can go let OP equal to the original price of the calculator. And it really should be the cost, is what they would call it in business. That would be the cost that it cost the business. Okay. So now let's create our equation. We have everything that we have. We wrote down our knowns, and we created our unknown. So let's see, how do we create our equation? That comes from right here. I showed it to you. So the selling price, we talked about it, is going to be the original price plus the markup. Correct? What is the markup? The markup is always a fixed percentage of whatever you paid originally. So in this case, it will be R multiplied by OP is equal to SP. Okay. Alright? So in our case, what do we have? We have OP is something we are looking for, plus R is 0.15 of OP is equal to 78.50. it's already in terms of one unknown. Even though it looks like two variable letters, it's really one unknown. So we just add them up on the left, so we get 1.15 OP, because this is 1, and you're adding that, should equal to 78.50. I want to solve for the original price, so I divide both sides by 1.15, so I get OP is equal to 78.50 divided by 1.15. And if you do that on your calculators, you should end up with some value for it. In this case, it is 68.26087. Whenever you're doing word problems, it's a very good idea to round off your answers to two decimal places. So in this case, we'll just chop off here. This number is less than 5, so we don't need to round up. So the answer is the original price is $68.26. So that's how much the bookstore paid for the calculator, and they marked it up by 15% of that to sell it to the students for $78.50. So again, we didn't really have a formula for this, but we were able to make one up very quickly by using the ideas from business on how they mark up prices. The next problem is exactly the same as this, except instead of looking at markup, we are looking at markdown, because you're looking at a sale item. So let's do this one. They say the shirt is on sale for $15. So the sale price, I'll just call it S this time instead of SP. The sale price is $15. Okay, and has been marked down by 35%. So the rate at which it was marked down is 35%. So the question is, how much was the shirt being sold for before the sale? So the original price you're looking for again. So let's create a variable this time. So let's go let X equal to the original price. I'll do it a little bit differently this time. Original price of the shirt before the sale. Okay, so how different will be this problem compared to the last one? Since it's a markdown, what are we going to do? Think about it. To figure out your sale price, if you're buying something on sale, you would take whatever the original price was, okay, minus the markdown, how much you got off. Correct? You got some discount because it's on sale, and when you subtract that, you'll get your sale price. Okay, so let's do that. I called it S, didn't I? Yeah. So let's do that. So what's the original price of my shirt? It's called X. So let's put that X minus. What is the markdown? Markdown is 35% of your original price. So it'll be 0.35 times X. That'll tell you the markdown, how much you got off. Should equal to the sale price, which is $15. It's already in terms of one variable, one unknown. So we just add the left hand side up. Okay, so if you add the left hand side up, we get what? 0.65 x, because this is 1, so 1 minus the other coefficient is 15. To solve for x, to isolate x by itself, you divide both sides by 0.65, so you get 15 divided by 0.65, which will give us, if you divide this, we'll end up with what? 23.0769. Okay, so we'll round off right there. This is bigger than 5, so we'll round up the 7. So the original prices was $23.08. So that was the original price of that shirt. Okay. The next problem has to do with motion. So let me go ahead and give you some background on motion first. So let's talk about motion for a second. And we're not only talking about motion, we're talking about a special type of motion, uniform motion. That means the speed stays constant, it doesn't fluctuate. If the speed started fluctuating, then we would have to use a different type of math to do that. We'd have to use calculus to do that, as opposed to what we're going to do today. Okay, so in the rest of these problems that we're going to do the rest of the way, we're always going to have two quantities that we're going to have to deal with. So either we are going to compare the motion of two people driving, okay, or we're going to later on we're going to look at problems where two people are working together, or we're going to look at problems where we are mixing two different types of solutions. So we're always going to look at two different things. So it's really a good idea to do these problems by setting them up in form of a table, and we'll talk about how to do that, okay? But before I show you how to set up these problems in a table, let me go ahead and first give you the formula for motion. This formula is from physics. It's a very simple formula. It tells you that the rate at which the car is going, or the speed of the car, is equal to the distance it traveled divided by the time it took to travel that distance. Okay, I'm just going to write it in terms of capital letters. It's easier for me to write. R is equal to d over t. Now this is one formula for motion. Okay, I can easily come up with a different formula for motion by just being a little bit creative over here. Okay, if you think about it, this is over 1. I have two fractions equal, so we can cross multiply, correct? So if I cross multiply this, what do I get? I'll write 2. Let me do that first. Let me cross multiply, so you get RT is equal to D. 1 D times 1 is D. So this gives me the second formula for motion that tells me D is equal to RT. That's the second formula. The third formula for motion I can get out of this is I can divide both sides by R. And so if I divide the left by R, so I get D over R, I'm sorry, before I do that, is equal to RT over R. On the right here, the R's cancel, so we get the third formula for motion, which is T is equal to distance over rate. So you have three different formulas for motion. So now, depending upon the problem, we can use one of these formulas, and even if you use you can pretty much use any of these formulas. Just sometimes you might have to end up doing some extra work to get to the answer because you used one of the other formulas than the one you should have used, but it'll still all work out if you do the algebra correctly. So here's the one that I usually prefer to use. I'm sorry, not this one. I like to use this one just because usually they'll tell you something about the rate at which you're traveling and how long you've been traveling, so I prefer to use this formula for that reason. But like I said, sometimes in a problem it might be beneficial to use one of these other formulas, so you just have to adapt and use the other formulas. Okay, but majority of the time you will always end up using this one, okay, where distance is equal to rate times time. Rate is how fast you're traveling times the time you've been traveling that distance. Alright, so let's take a look at how to set up this problem in a grid. Anytime you're working with two quantities, like mixing two things, or two people working together, or two people driving, always try to set them up in table. You can do them without table. That's how they're done in the notes. So you can take a look at that, see if that's the method you prefer, or you can do them in form of a table. I just prefer doing them in table. I think students understand it better in terms of table. So let's take a look at this problem. Two cars are 500 miles apart. Are 500 miles apart and moving directly towards each other. One car is moving at a speed of 100 miles per hour and the other is moving at 70 miles per hour. Assuming that the cars started moving at the same time, how long does it take for the two cars to meet? So let me draw a picture. Again, picture is helpful in this case, so let's do that. So I have two cars. Let's say this is car A here. I'll draw a box. Is moving in this direction, and then there's car B here, which is moving in this direction. Okay, so since car A is traveling at 100 miles per hour, clearly it's going to cover more distance than car B. Okay, so eventually they're going to meet somewhere. Okay, they're going to meet somewhere in between. So together, since they were how many miles apart originally? They were 500 miles apart. So by the time they meet together, they would have traveled a distance of 500 miles, right? This car would have traveled, let's just say, for example, this car would have traveled 300 miles and this car would have traveled 200. So 200 plus 300 is 500. So together, or this car could have traveled 400 and this car could have traveled 100. So, but the bottom line is together, by the time they meet in the middle, not in the middle, but in between, they would have traveled a distance of 100 miles. Okay, I'm sorry, 500 miles. Now, so that's what's given to us in terms of a picture. Okay, we know that this car is traveling at 100 miles, this car is traveling at 70 miles per hour. They both started at the same time. So they both started at the same time and they started moving towards each other. So eventually when they meet, even though one car is going faster than the other, in terms of time, they both have been in motion for exactly the same time. Okay, so we don't know how long car A has been in motion, so let's say that's X hours. And car B also would be X because they've both been traveling for the same amount of time since they started exactly at the same time. So let's see how we can utilize all of this information. I just drew this picture for your benefit. If you don't want to draw that picture, that's fine, but it just helps to see it. So let's put it into a grid and see how this helps. We want to use this formula here. When we do the grid method, the table method, or the grid method that I call, you always want to write the formula backwards. That means you want to write RT is equal to D. Okay, so let's create a grid. And this is very similar to an Excel spreadsheet. If you guys realize that Excel spreadsheet says what? Rows and columns. That's exactly what it is. On the top row, I write my formula backwards. I write rate multiplied by time is equal to the distance. That's what I have. This row represents everything that has to do with car A. This row represents everything that has to do with car B. And there's your grid. Now, to use this grid method, all we have to do is fill in this, and this, because to find D, all you have to do is multiply the rate and the time, and then you can get D, the distance for car A, and then you can find this D value, because that's a D column, the distance for car B. So that's easy to do. So really we need to concentrate on only these four values. If I can fill these four cells here, if you can think of this as an Excel spreadsheet, you're done, because all you have to do is multiply each row to get the last column. Okay, so let's do that. What was the rate of car A? How fast was car A traveling? This cell here represents the rate of car A. Car A was traveling at 100 miles per hour. How fast was car B traveling? This is the rate of car B. That was 70 miles per hour. So you can see how easy it is to fill the grid up because everything is given to us. Do you know how long car A was traveling? T is the time car A was in motion. We don't know that, so let's call that X. We don't need to define X. We don't have to say X is equal to the speed time the car A was, because from this table it's obvious X is the time for car A. And then car B was traveling also at X miles per hour because they were both traveling for the same amount of time, because they started at the same amount of time and they kept driving. The distance now is easy. How do you find the distance that the car A traveled? All you do is multiply the rate of car A times how long it was traveling. So it'll be 100x. The distance that car B traveled would be 70x. So the distance column is really always easy to find. All you have to do is multiply the rows and you get the distance, because we're using distance as rate times time. Now that we have a grid filled up, we have to create the equation because we need the equation to solve. How do I create the equation? The equation comes from any additional information that's given to you, and usually it'll have to do with the distance or have to do with the time or something. Do you guys follow? So let's take a look at the equation that we can create here. Okay, they've told us that the distance that the car A traveled plus the distance that the car B traveled should equal to what? 500 miles, shouldn't it? We can see that from the picture. This is the distance car A traveled. This is the distance car B traveled. Together, since they were 500 miles apart when they met, they would have traveled a total of 500 miles. I do know what the distance car A traveled. This is my distance column here, and this is the distance of car A because that's my distance row. That's easy to find. That's what? 100x. What is the distance car B traveled? Again, the distance column, car B. That's 70x is equal to 500. There's your equation. One unknown. We know how to solve this, right? It's fairly straightforward. What do? We multiply and solve. So what do we get? We collect the x terms on one side, which they already are, and then we add them up. So we get 170x is equal to 500. And then to isolate x by itself, we divide both sides by 170. So we get 500 divided by 170. So we get 50 divided by 70, which is 2.94117. 2.94117. We want to round off to 2 decimal places. So that tells me that it took them 2 hours, 2.94 hours to meet. Okay. X represents the time each car was traveling, so we did that. So that's how we do the motion problems. It's uniform motion, they're always traveling at the same fixed speed. So we use this formula to set it up, and again, I usually prefer that, but you could have been a little bit creative and tried to figure out how to use some of the other ones too, and it would have worked out. Let's do the same problem again, except this time they've told us that this time assume that the faster car will start 1 hour after the slower car. Okay, so let's do this problem again. Let's put it into a grid. It's a motion problem. As soon as you know it's a motion problem, create a grid, because you'll always be comparing two things in this class. You take your rate, you multiply that by your time, and you end up with your distance. This is car A, this is car B. Okay. They already told us car A was traveling at 100 miles per hour. This R represents the speed or the rate of the cars. This represents car A, so that's 100 miles, and this was 70. Okay. Now let's take a look at the setup. Okay. And by the way, over here, if you wanted to in this problem, you could have called this last row the total row, and you could have put 500 here because that's the total distance. This is the distance, this is the total. That would reply the total distance traveled would be 500. So you know that this is the distance car A plus car B should equal to 500. So you can get that equation from this last row also. Okay. Alright. So let's take a look at this problem. Now, what they've told us that these two cars are not traveling for the same amount of time. Car B started earlier than car A. So let's say the car B was traveling for X hours. We still don't know how long it was traveling, but we just know it started an hour early. Okay, so if car B was traveling for X hours, how long was car A traveling then? So let's think about it. Okay, just to give you a concrete example, let's say car B was traveling for 6 hours before it met car A. Then car A would have been traveling for 5 because it was traveling for 1 less hour because it started an hour later. So it wasn't in motion for the same amount of time as car B, but it was in motion for 1 less hour. So if car B was traveling for X hours, car A, the time for car A would have been what? X minus 1, because it would be 1 less hour. So the distance, again, like I told you, the distance column is easy to fill. All you have to do is multiply the rows. So we get 100 times x minus 1. Put parentheses here because these are two quantities. And then you get 70x. And if you call this my total, this would be 500. Because the total distance they would still travel is 500. Even though the faster car started an hour later, it's still going to cover the same distance together with the other car. It's going to cover 500 miles. So we know that the distance traveled by car A plus the distance traveled by car B should equal to 500. That should be my total distance. Distance traveled by car A, this is my distance column here. This is my car A row. Should be 100 times x minus 1 plus distance traveled by car B, 70x, is equal to 500. Again, it's a linear equation now. It's got only one unknown, so it's easy to solve. Get rid of the parentheses first. So we get 100x minus 100 plus 70x is equal to 500. Okay, so you just need to rearrange everything now so that it all works out the way you want. I can keep these two on the left, so I get 170x, and then move the 100 to the other side, so we get 600. So we get x is equal to 600 over 170, and I'm going through this a little bit faster than usual, but by now you should know how to solve linear equations. So we get 3.5294 and so on. So we want to round off to 2 decimal places. Okay, so what does that tell me? What did we find x? Go back to your grid and see what x is. X is the time car B was traveling. Okay, so we can say car B was traveling, okay, for 3.53 hours, and car A was traveling for how many? Car A would be x minus 1, so it'll be this minus 1, so it'll be 2.53 hours. So there's your answer to that problem. So I'm hoping you guys understand how to do these motion problems. Because we are looking at two quantities, it's always a good idea to put them in a grid or a table and write the formula backwards. Rate times time is equal to distance, and do it. Let's do one more problem on motion. We have two boats start about 100 miles apart and start moving, okay, start moving to the right at the same time. Okay, boat A on the left is moving at twice the speed as boat on the right. Okay, so let's draw a picture to see how it is. Here is boat A, okay, and it starts going in this direction. Okay, then there's another boat, boat B, which is 100 miles away from boat A. Okay, so let's say boat B is here. So this distance from here to here is 100 miles. And boat B also starts traveling to the right. Now because boat A is going faster than boat B, which one's going faster? The boat on the left is moving at twice the speed as the boat on the right. Okay, 5 hours after starting on the left, the boat on the left catches up with the boat on the right, so eventually they catch up. Okay, so this is the setup. So here is how far apart they were. They were 100 miles apart, and then boat A was traveling faster than boat B, and then they kept driving, and after 5 hours they caught up with each other. Okay, so let's see if we can set up this problem. Okay, so we'll do a grid business and do it. So we have rate multiplied by time is equal to distance, boat A and boat B. Okay, alright, so let's see. Two boats start at 100 miles apart and move to the right at the same time. The boat on the left is moving at twice the speed as boat on the right. That means boat A is going twice as fast as boat B. Do we know how fast boat B was going? They didn't give us that this time, so let's call that x. So in this case the speed of boat A would be 2x. It will be twice the speed of boat B. Okay, 5 hours after starting, the boat on the left catches up with the boat on the right. So they both had been in motion for the same amount of time. They just started at different positions, but they've been in motion for the same amount of time, which is 5 hours. So they've been traveling for the same amount of time. Once we know that, we can find the distance easily. All we have to do is multiply the rate and the time. So we get 10x and we get 5x. Okay, then what do we want to do? We want to set up our equation to solve for x. So let's do that. Well, let's take a look at what we have. Eventually when they catch up, what can you tell me about their distances? Okay, you can say that the distance that boat A traveled, that's this distance, would equal to the distance that boat B traveled plus this extra 100 miles that they were apart to begin with. So we know that the distance that boat A traveled should equal to the distance that boat B traveled plus 100. You can see that from the picture. This is the distance boat B traveled. This is the distance boat A traveled. this distance should equal to this plus this 100 miles that they were apart. What is the distance boat A traveled? That's this number. This is my distance column. That's my row that reflects A. So that would be 10x should equal to 5x plus 100. And that's it. We just need to solve for x. We move all the x terms to one side. It's a linear equation in x. It's degree 1. So we get 5x is equal to 100. So we get x is equal to 20. You divide both sides by 5. So we can say that the question was, how fast was each boat going? Boat A was moving at, here's the rate of boat A. Do you guys see that? It'll be 2 times x. X was what? 20 at 40 miles per hour. And boat B was moving, boat B was moving at 20 miles per hour. Okay, so there's your answer to that problem. So I'm hoping after doing 3 of these motion problems you feel a little bit more comfortable with them. As you do your practice problems, might get easier. Let's move on to the next topic. Okay, the next topic has to do with work. So we have to come up with some formulas. Okay, we have like 2 people working together and we want to know how long it'll take if they work together or if they do it alone, sort of thing. So let me give you the formula first. These are work formulas. Okay, the formula for work is simple. Think about it. What would be the formula for work? It'll depend upon how fast you can do the job, how long you've been working. So if you multiply those two, that'll tell you how much of the job you've completed. So basically the formula for work is rate of work, how fast you can do the job, multiplied by time working, should equal to task completed. How much of the job did you finish? This is just a simple common sense formula. How fast can you work times how long you've been working. If you multiply those two, that'll tell you how much of the job you finished. Okay, I can abbreviate it and write it this way. Rate of work, I'll just put ROW, multiplied by time working, TW, should equal to task completed. So this is a formula we're going to use. It's already written backwards. Whenever we put some formula in a grid, we always write it backwards, so it's a good idea. Now before I go any further, let me explain what rate of work is. Let me go. Rate of work is equal to the amount of job, or it could be task, job completed in 1 unit of time. Okay, so the rate of work is how much of the job can you do in 1 unit of time, and the unit is capitalized there, 1 unit. For a reason is because that unit could be different. It could be, unit of time could be hours, it could be weeks, it could be days, it could be months. It's basically anything that has any unit that has to do with time, years, and so on. So that's what it is. We don't know what it is. From problem to problem it might change. In one problem it could be hours, in the next one it could be years. Alright, how do I calculate rate of work? So let me give you an example of that and hopefully that'll explain it better. So let's say that Tom can paint a room in 5 hours. So if I tell you Tom can paint a room in 5 hours, what is his rate of work? Basically, what does that mean? According to this definition, how much of the room can he paint in 1 hour? Well, so Tom's rate of work would be what? It'll be 1 over 5. Because if it takes him 5 hours to paint the room, then in each hour he would paint 1/5 of the room. So like for example, just to show you, okay, so let's say here's a breakdown of his job. Okay, this is hours, this is the job. Okay, this is the first hour, second hour, third hour, fourth hour, and the fifth hour. So now he starts painting the room. After the first hour, he would have painted 1/5 of the room. After the second hour, since 1 hour has passed, he would paint another fifth of the room. The third hour, he'll paint another fifth. Fourth hour, another fifth, and the fifth hour, another fifth. And you can see, if you start adding up all the job he's done, each hour he's painting 1/5 of the room. So you add up all those 1/5s. That'll tell you how much of the job he's done, right? So if I add them up, the common denominator is a 5. On the top you get 1 plus 1 plus 1 plus 1 is 5. That gives you 1. So he would have finished that one room. He would have finished painting that one room. Because at each hour he does fraction of the room. And at the end he'll do that whole room. If you add up all those fractions, you should get a whole, because he would have finished that room. So his rate of work reflects how much of the room he can paint in 1 hour. It's always 1 over however long it takes him to paint the room. So please remember that. That's what rate of work is. So for example, another example, if it takes John 6 hours to mow the lawn of his house, what is his rate of work? It'll be 1/6, because in 1 hour, each hour he would do 1/6 of the lawn. So it's in each unit of time he would do 1/6 of that lawn. So let's take a look at this example. So this is any problem to do with work. So you have an office has 2 envelope stuffing machines. Okay, machine A can stuff a batch of envelopes in 5 hours, and machine B can stuff the batch of envelopes in 3 hours if they were just working on their own. So the question is, how long would it take the 2 machines working together to stuff the batch of envelopes? So let's create a grid and do it, because these are 2 things we're comparing. So it's a good idea to create a grid. So this is my formula, rate of work. If you multiply that by time working, it should equal to the task completed. Okay, I have 2 machines, machine A and machine B. They've told us that if machine A was doing the job alone, it would take him 5 hours. Okay, so what is the rate of work of machine B? A. How much of the job can he do in 1 hour? It would be 1/5, because it takes him 5 hours to complete the entire job. So each hour the machine A does 1/5 of the job. Machine B can do the same job in 3 hours by itself. So in each hour it would do 1/3 of the job. Okay, now you start both the machines and they both start working together, and at the end of some time they would have both finished the same job, right? Because they would have finished that job because they're both working together. Each one is doing part of the job, and together at the end of a certain time the job would be done. So if they both work together, they're working for the same amount of time, because they both start at the same time and they keep working till the job's done. Okay, so we don't know that time, so let's call that x. X is the time that machine A was working, and X would be the time that machine B was working, because they were working for the same amount of time, because they both started at the same time and they kept working till the job was done. So when they stopped, they both worked for the same amount of time. So what is task completed? Well, task completed you get by multiplying this row, just like we did with the disk motion problems. So if you take 1/5 and multiply by x, you get x over 5, because this is over 1. So you get x over 5. Similarly, we get x over 3. Okay, so let's take a look at each of these numbers and get a better understanding of them. What does this first number represent? Okay, that is the row for machine A, and that is the column for task completed. So this represents the amount of the task machine A completed in X hours. So that is the amount of the job machine A completed, and this is the same thing, except instead of A it would be B. So if this is the job that machine A did, this is the job that machine B did. Okay, if you were to add them up, wouldn't that give you the entire job that they both finished? Because by the end, when they start together working, and they work till they stop, till when they stop, the job is done. They've finished that one job. So we know that if each machine does fraction of the job, this is the fraction of the job machine A did, this is the fraction of the job machine B did. So we know that x over 5 plus x over 3 should equal to 1. Just like over here in this example, if you keep adding up the rate of work for 5 straight hours, you would get 5 over 5, which is 1, because at the end of 5 hours, since the rate of work is 1/5, they would have finished, the Tom would have finished painting that room. So with the work problems, each person does a fraction of the job, and together, when you add those fractions up, it should give you the whole, because together they would finish that one job. So now this is a problem that has an equality in fractions, so we want to find the common denominator, which is 3 raised to 1 times 5 raised to 1, which is 15. You take each factor to the highest exponent, so you multiply each term by 15. We've done this before, so let's do that. We can't cross multiply here because we just don't have two fractions. We technically have three fractions. Out here 5 goes into 15 3 times, so we get 3x. Out here 3 goes into 15 5 times, so we get 5x is equal to 15. So we get 8x is equal to 15. So if we want to solve for x, we get x is equal to 15 over 8. Okay, so if you end up with 15 over 8, that tells you what is x in this problem. X is the time they were both working together. So if we have 15 over 8, we just have to divide that out to come up with a decimal, which is 1.875, and we can round it off, so you get 1.88 hours. So it would take them 1.87 hours to complete the job. Because if they were working together, that's how long it would take them. So let's go on to the next problem. It's another work problem. So let's right away start a grid. So we have rate of work, time working should equal to task completed. So we have Mary can clean the office complex in 5 hours. So we have Mary. So what is a rate of work if it takes her 5 hours to clean the office? It's 1/5. Okay. Working together with John, so she's going to be working with John. Mary and John can clean the office complex in 3.5 hours. If they work together, it would be done in 3.5 hours. How long would it take John to clean the office complex by himself? So this time we do not know how long it would take John to clean the office complex by itself. So let's create a variable on the side for it. Let x equal to the time it takes John to clean. Okay, so if John can do the job in x hours, what is his rate of work then? How long can he do, how much of the job can he do in 1 hour? It'll be 1 over x. So that's a little bit different here, so bear that in mind. You don't want to put x here. Do you guys follow? You want to put his rate of work. If he can do the job in x hours, his rate of work would be 1 over x. And time working, if they work together, they're working for how many hours together? 3.5. So time working would be 3.5. So the task completed is easy. You just multiply each row, so you get 3.5 divided by 5, and you get 3.5 divided by x. So this is the job that Mary did. This is the job that John did. Each one does a part of the job, fraction of the job. So if you add those fractions, you should get a whole, because they would have finished the whole job. Because they're working together, they would have finished that entire job. So you should end up with 1. This is again an equation that has fractions, so we want to multiply by the common denominator. We have 5x is my common denominator because the power is just 1 on each. So you multiply everything by 5x. Out here the 5's cancel, So we get 3.5x plus the x's cancel here, and then we'll have to multiply that out. Okay, so we'll end up with 17.5 is equal to 5x. Okay, and then it's just a matter of solving for x. Move x terms to one side, so I'll move it to the right. I'm sorry. 17.5 is equal to 5x minus 3.5x. So we get 17.5 is equal to 1.5x. So you get x is equal to 17.5 divided by 1.5. You divide both sides by 1.5. So you end up with 11.67 hours. Okay. So it would take John 11.67 hours to do the job alone. And I'll let you write that on your own. You do need to write it as a sentence. I'm just going to let you do that since I want to move on to the next problem. The next two problems have to do with mixture. So again, we'll have to come up with a formula for mixture. So let's do that. So these are mixture formulas. We today looked at three new formulas: motion, work, and mixture. Okay, so the formula for mixture is this. Okay. If you have amount of solution and if you multiply that by concentration of substance, should give you what? So if you have some solution, okay, and like let me give you a concrete example. So let's say you have 12-ounce can of beer. That's my solution. Okay, and if I multiply that by the concentration of alcohol, so let's say concentration of alcohol. I'm interested in the concentration of alcohol in the beer. The side of the beer can tells me that the amount of alcohol in the beer is 20%. Okay, so if I were to multiply these two, what do you think it'll give us? What do you think the number will represent? Okay, so if I have 12-ounce can of beer, and if so I have 12, and if you multiply that by 0.2, if you change that to a decimal, you'll end up with 2.4 ounces. So this is the amount of beer. What is this the amount of? Okay, that is actually the amount of alcohol in the beer. This tells you the concentration. So if I take my concentration and multiply it by the amount of beer, that'll give me the amount of alcohol. So this tells me the quantity of alcohol. So the quantity of alcohol in this case is 2.4 ounces. So not the whole can of beer is all alcohol, because they mix other things in it, water and things like that, to create that beer. So out of all of those other things in the beer can, only 2.4 ounces is alcohol. Everything else is other substances. So in this case, if we were to multiply these two, I would get the quantity of substance, whatever I'm interested in. In the example that I just gave you, I was interested in alcohol, so my substance was alcohol, my solution was beer. So if I multiply that, I'll get the quantity of alcohol in that can. So that is a formula we're going to use here. So in terms of variables, I'll say A is the amount. The concentration, we can just call that C. C is the concentration, and Q is the quantity of the substance. So that's a formula I'll use. There's no set formula for this. I'm just creating some letters for it from this actual formula. Okay, so let's take a look at how to set up this problem in terms of a table, because we're going to be mixing two things. That makes sense though. Think about it. You know, if you have beer, like say you have 12 ounces of beer, that's 20% alcohol, and then you have another 20 ounces of beer, that's 30% alcohol. If I were to mix this, I would end up with what? Well, if I mix 12 ounces with 20 ounces, I would get 30 ounces of beer, okay, which is at how much alcohol? what concentration will this be at? Well, I don't know that. It's not going to be at 50%. You can't mix 20% and 30% and get 50% alcohol in it. That makes no sense. It's going to be somewhere in between. So it's going to be somewhere in between here. The concentration is going to be, I don't know what it is. It'll be anywhere between 20 and 30% alcohol. Because when you mix two quantities that have different concentration, you're basically diluting it. You're going to end up with something in between the lower concentration and the higher concentration. You're not going to end up with the sum of the concentrations. Okay, so in this case, let's take a look at this problem. Let me write my formula. Amount multiplied by concentration should equal to the quantity of whatever we are interested in. I always write down what we are interested in right here. So let's take a look at it. What are we working with? They've asked us how much of 50% alcohol solution should be mixed with 10 gallons of 35% solution to make 40% solution. So let's take a look at it. Okay, 50, 35, and 40. So we're looking at alcohol. That's what we are looking at. Okay, so we have two different types of solutions. So I'll call solution 1 and solution 2. And this is going to be my mixture because I'm going to mix them this time. So they said what amount of 50% alcohol solution. So the concentration of that first solution is 50%. So I'll put 0.50. And do we know the amount of it? We don't know that. So we're going to mix, we don't know that. We're going to mix that with 10 liters or gallons or whatever it is. 10 gallons of another solution that's 35% alcohol. The amount of alcohol in this solution is 35%. To create a mixture that's going to be 40% alcohol, you can see it's between the higher concentration and the lower concentration. That's what happens when you mix. So how much solution do we end up with? It'll be x plus 10. If I take x gallons and mix it with 10 gallons, I should get x plus 10 gallons. And that's it. We just fill our grid. How do I find the quantity? According to the formula, you take the amount and multiply it by the concentration. Here's the amount, concentration. So you get 0.5x, 0.35 times 10, and we get 0.4 times x plus 10. We put parentheses because we have two quantities here. And that's it. So we set up our grid. Now we have to create an equation because we ultimately have to solve for x. Well, this is the amount of alcohol in the first solution. This is the amount of alcohol in the second solution. And this is the amount of alcohol in your mixture. Well, shouldn't this last column add up? Shouldn't the quantity of alcohol in the first solution plus the quantity of alcohol in the second solution equal to the quantity of alcohol in the mixture? It should, because if you're mixing the amount of alcohol in each solution, that should give us a total alcohol in the mixture. So we get 0.5x, that's the quantity of alcohol in the first solution, plus 0.35 times 10 is equal to 0.4 times x plus 10. Let me get rid of this. So there's my equation. It's already in one unknown. It's in one variable, so it's all set up for us to do. All we have to do is get rid of the parentheses. So we get 0.5x plus 3.5 is equal to 0.4x plus 4. I'm just distributing here. Move the x terms to one side. 0.5x minus 0.4x is equal to 4 minus 3.5. So I get 0.1x is equal to 0.5. Okay. So you divide both sides by 0.1, so you get 0.5 divided by 0.1. That gives you 5 gallons. Okay. So x is 5 gallons, so that tells us we should mix 5 gallons of 50% alcohol solution with 10 gallons of 35% alcohol solutions to create a 40% solution. Okay. Again, I really would appreciate it if you write your answers in terms of a sentence. I'm just going to not do that right now for the sake of time because this video is already getting long. So I'm just going to go on to the next problem, but make sure you guys do that. This is the last problem. Again, a mixture problem, so let's start with a grid. Okay. It's not a bad idea for you to pause the video and set up these problems as you're going along and then check your setup with mine. Okay. So we have 40% acid solution. So this time we are looking at acid. Okay, this is the amount multiplied by the concentration should give you the quantity of acid. So we're looking at quantity of acid. Okay, so they ask us, we have 40% solution and we want 75 liters of 50% solution. Okay, how much water should we put in the 40% solution to do this? So this is what we have. We have a solution, and then to that solution we're going to add water to create a mixture. Okay, now we already have a 40% solution and we're going to end up with a 75 liters of 15% solution. That's what we want to end up with. Okay, so we start with 40% and we're going to end up with 15%. So we're going to add water to dilute it, so that way it's not so concentrated. So the amount of the total mixture is going to be 75 liters and it's going to be at 15%. So it's going to be at 0.15. I hope you realize that. That's what we want to create. We want that mixture. And to get that mixture, we're going to mix 40% acid solution with water. How much water is in acid? There's no acid in water, so the concentration of acid in water would be 0 here. So remember, this is my concentration column. That the C tells you how much acid is in the solution. Since water has no acid, it's going to be 0. Okay, so the question is, how much water should we put in the 40% solution? So do we know the amount of water we're going to add? No, so let's call that X. Okay, so I'm going to start with some solution. I'm going to add X liters of water and end up with 75 liters. So how much did I start with? How much do you think we started with to get to 75? Think about it. I want to eventually end up with 75 liters. Okay, so I'm going to take X liters of water and I'm going to have to add how much of the solution to get that. It's going to be 75 minus X, right? Because when I add these two, the X's will cancel and I'll get 75. Okay, so eventually I want to end up with 75 liters. Out of that 75 liters, X liters is going to be water. Do you guys agree? So how much is left for the solution? It will be 75 minus how many ever liters of water you had. So now to find the quantity, we just multiply the rows. X times 0 is just 0. With the mixture problem, the last column always gives you the equation, because we know that the concentration of acid in the solution plus the concentration of acid in the water should give you the concentration of acid in the mixture. So we know that the concentration of the the amount or the quantity of acid in the solution plus the quantity of acid in water should give you the quantity of acid in the mixture. So in the solution is 4.4 times 75 minus X. In water it is 0, and out here it is 75 times 0.15. And now it's just a matter of getting rid of the parentheses and solving. Okay, and that's all we need to do over here to solve for this. Okay, nothing fancy or anything like that. So we get 30 minus 0.4x is equal to, when we multiply 75 times I should get 11.25. Okay, so let's solve for x. Move this on the other side, move that here. So we get 30 minus 11.25 is equal to 0.4x. So we get 0.4x is equal to 18.75. So we get x is equal to 18.75 divided by 0.4. So we get x is 46.875. So that's how many liters of acid we need to begin with. Okay, of water we need to dilute that original original solution, so that it ends up with only 15% acid. The original solution had 40%, so we're going to mix it with this. We'll round it off, so the actual amount is 46.88 liters. And again, you do need to write the answer in terms of a sentence. This was a long video because it is a difficult topic, and I'm hoping that you guys will practice some of the problems that you have for homework, so that way you have a better understanding of how to do word problems. And once again, let me reiterate what I said at the beginning. The more problems you do, the more confidence you're going to get. So if you don't know how to do something, just pause the video, go back and look at the video. I'm sorry, do the problem, and if you don't know how to do it, go back to the video and take a look at it. Okay.